This is GATE 2014 Set 1 electrical question number 19. Power consumed by a balanced 3-phase 3-wire load is measured by the 2 wattmeter method. First wattmeter reads twice that of second, then the load impedance angle in radians is being asked. 4 options are given. For NPTEL reference, you can refer to the lecture series on network signal and system by Professor L. Umanant, Professor Department of EECS, IISc Bangalore, lecture 33, 3-phase system, 4th part. Now in order to solve this question, we need to know that for a 3-phase AC supply R by B, where it is like this, R then Y then B, the sequence, then if you connect a wattmeter whose current coil is this attached to R phase and the pressure coil, current coil, second wattmeter current coil, it is along the B phase, and the pressure coil of this is connected with the pressure coil of the first wattmeter in this fashion. If the load line voltage is VL and the load line current, that is the load side line current, is IL, then the wattmeters will read like this. W1 reading will be VLIL cos 30 minus 5. Wattmeter 2 reading will be VLIL cos 30 plus 5, where 5 is the power factor angle. Now I want to say that if for the load side, this W1 and W2 will read the net power, that is load power. Now if the active power consumed by the load is P and the reactive power is Q and S is the actual power, then power factor angle phi cos phi equal to P by S. Similarly, for the load having the impedance Z with resistance R and reactance X, this will be phi also. So the load impedance angle and the power factor angle are same, only the power factor is cos of that angle, phi. Load impedance angle is phi. Wattmeter is twice that of the second wattmeter reading, so W1 equal to 2W2, then tan phi, we can apply that formula, equal to W1 is 2W2, so 2W2 minus W2 is W2 divided by 3W2 into root 3, so it is coming out equal to, implies phi tan inverse 1 by root 3 implies that phi equal to 30 degree, which is equal to pi by 6. So the correct option is option C, pi by 6. Thank you.